Okay, our next unit is going to be geometrical optics, which is all about how light gets bent by mirrors when the light bounces off of it, or by lenses when the light refracts through them, and how we end up seeing images when the light gets bent. So, the way we see things is light reflects off of that into our eyes. And our brain knows that light usually travels in a straight line. So when light enters my eye this way, my brain extrapolates back along that line, and I see the object back along that line. Now, what's going to happen is there's going to be light in the room or whatever, and it's going to come down and it's going to reflect off of this person's foot. It's going to reflect in every direction, and one of the rays is going to reflect off of this foot, hit this plane mirror, a flat mirror, and then reflect into his eye like this. Now, since our brain knows that light almost always travels in straight lines, excuse me, we're going to label this the actual path of the light. Since our brain knows that light travels in straight lines, it's going to think that that light came from back along this line, along this apparent path of the light, and he's going to see the foot back over here. And that's going to be true for every point in his body. So for his hand, the light's going to come off of here, reflect off of the mirror into his eye, and he's going to see the hand back in here. And he's actually going to see an entire image of himself back behind the mirror. Now, he's really not inside the mirror, so that's an image. The object is the real thing, the image is what we see. And most of this unit is going to be about describing the images we see. And in this case, the image is right side up, okay? It's the same size as he is, okay? It's reversed left to right. You know, when we read, like we're wearing a shirt and we read it in a mirror, it's going to be backwards, okay? And we're also, in this case, going to say it's virtual. We'll talk about what virtual and real means as we go along. Now, this may not always be true. It's always true for a plane mirror, but if I have a curved mirror, the image can be upside down or right side up, it depends, okay? And it's not always the same size. It could be shrunk or it could be magnified. If you think of a funhouse mirror, it makes things get magnified or shrunk. So now we're going to start dealing with curved mirrors. And at first we're going to talk about converging mirrors and lenses. To converge means to come together at a focal point. So the light that comes in here parallel is going to bounce down to that focus. Light that comes into this lens parallel is going to refract as it goes through and end up at the focus. And you've seen this in real life with radio antennas, okay, a dish antenna. The radio waves are all coming in and hitting this dish, and then they get reflected down to a single focus, and that's where you would put your antenna. So it's collecting all of the energy hitting that whole dish into one little spot. For this, if you take sunlight and put it through a magnifying glass, the sunlight gets concentrated, and maybe you could set a piece of paper on fire. It also works in reverse. For this here, if I put a light source here, the light's going to go outward, and then all the light that hits the mirror is going to come back out parallel, and that's how a searchlight beam works. When we do the math, that's going to have a positive focal point. So just as we get to the math, remember, for converging mirrors, the focal point is positive. Now there's some memorization. These problems are not really very hard, but if you don't know that a concave mirror is converging and a convex lens is converging, then it gets a little bit confusing. Now, this is concave. Think of concave, the light is going into the cave, okay? Concave means the light's going into it, like into a cave. Convex means, for this lens, that it bows out in the middle. So those are vocabulary words that we need to know. And then these types, as I said before, can form images which are either right side up or upside down. They can be magnified or shrunk, and they can be real or virtual. So a plane mirror can only form right side up, regular sized images, but these curved mirrors and lenses can do a lot of different things. Now, we're going to do ray diagrams to figure out where the object is going to be, like we did for the plane mirror. You trace where the light's going, where it seems to be coming from, and you use that to figure out where the image is. We have to draw at least two of the following three lines. We know the light that comes in parallel goes through the focus. We haven't talked about this yet, but light that goes through the center continues to go straight through the center. And light that goes through the focus comes out parallel. It's the opposite of this. If it comes in parallel, it goes through the focus. If it comes from the focus, it's going to go out parallel. And the image is formed where the rays meet. So our first example is going to look like this. And, I didn't say this, but for a mirror, the center is at 2F. So if I think of this mirror as being a big circle, there's the center of the circle, and the focus is halfway to the center. And that's something we need to memorize as well. But now, I'm going to go ahead and I'm going to try to draw at least two of these three lines. You're going to need to use a straight edge, so before you go on, grab a straight edge. Now, the first thing we're going to do is light coming in parallel is going to go down through the focus. So we draw that. We use our straight edge to draw a line that's parallel to this axis, hits the surface, and then we reflect it through the focus. The other one we're going to draw in this case, is straight through the center. One that goes straight through the center just continues on straight. Where they meet is where the image is. So you draw your image as an arrow pointing from the center line down to where they meet. In this case, they're meeting below it, so it's going to be pointing down. And you'll notice that the image is upside down, it's pointing downward, smaller, okay, it's smaller than the original, and it's what we call a real image. And we have to write down what a real image is. A real image is formed when the light actually gets to where the image is. So this light can actually reflect off the mirror and end up here. This light can actually go straight through the center and end up there. So when the light gets to the image, we call it a real image. So I could put a screen there, or I could put some film there. Since the light gets there, I'll be able to see this image on the film, or I'll be able to, on the screen, or I'll be able to capture it on film. Now, an example of this is a telescope. We have an object that's very far away. It's more than at the center. Okay, and if we're looking at a telescope, we might be looking at a star that's very far away. And the image it forms is going to be real. It's going to be small and upside down. Now you think, don't telescopes magnify things? But really, if you think about it, if you're looking at a star, that star is gigantic, the size of the sun. The image you're seeing isn't nearly that big. Okay? Now, our next example, we're going to start moving the object closer. So now it's going to be between the center and the focus. And this is going to be a turning point. When it's way out here, we know it's small and upside down. Let's see what happens when we get it between these two. So you got in your head, remember, what are the rays that we draw? First one we draw in parallel goes down through the focus. So take your straight edge, draw one parallel till it's the mirror, then down through the focus. The second one just goes straight through the center from the top of the object. And where they meet is where the image is. And look at that image. It is upside down, it's larger, and it's real, because the light actually gets there. So the difference is, when the object was over here, we ended up with a small image. When the object moves between the center and the focus, we end up with a larger image. So that center point is a turning point. Now, in a use for this is a slide projector. We put our slides in the projector, and we want to project them against a screen, okay, and you want the image to be big compared to the slides. So, and we know we can form it on the screen because it's real. The light is actually going to get there. Turns out they get flipped upside down, so what you have to do is put your slides upside down when you put them in the slide projector in order to project them right side up. Our example 3, we're going to move it closer. So now we're inside the focus. So here's the focus, here is the center. Draw the same rays. Parallel, down through the focus, and through the center. Now you notice what's going to happen is these two are never going to meet. Okay, and what do we do in that case? Well, we could extend these lines back this way and they would meet, but the light can't get back there. So we're not going to draw them as solid lines, we're going to draw them as dotted lines. and where they meet, we're going to draw in our image. And this time it's going to point up, because you always draw from the center line to the meeting point. So there it is. So again, this is now a turning point. When I was over here, it was upside down. When I'm in here, it's right side up. So the image is right side up, larger, and virtual. Virtual meaning the light doesn't actually ever get to that point. So if I was over here, I could see this thing magnified, but I couldn't form it on a screen because the light isn't getting there. An example of this is a makeup mirror. With a makeup mirror, you want to see a magnified version of your face so you can be real particular about where you're putting the makeup. Example 4, we're going to start dealing with lenses. And I'm going to draw something on here. I'm going to draw a center line through the lens. Now, a lens, the center is in the middle of the lens. It's no longer out at 2f. I have 2 focal points because the light, I could put my object over here and the light will go like this and then down through this focus. But I could also put my object on this side and then the light would go back this way. Now, what's going to happen to the light going in parallel? You're going to draw it this way. And this actually isn't true. Okay, I'm going to draw the light so that it goes in parallel and goes all the way to the center line before it bends down through the focus. That's not really what's happening. What's really happening is when the light goes from the air into the glass, it's going to refract there, and then when it goes glass back to air, it's going to refract there. So really, it bends twice. But in terms of how this works out, it actually ends up being correct in terms of finding the image to draw it as if it's going all the way to the center and then only bending once. Now our second line goes straight through the center. We don't reflect back off of lenses, we go through them, and they're going to meet over here. Now again, I'm past 2f, so that's considered far away. When you're far away, you get a small upside down image. So it's upside down and it's smaller than this original. Alright? So upside down, smaller, and real. Our next example, we're going to put the object inside the focus. So I'm skipping the one where it's between f and 2f. Now, we draw in our rays, parallel down through the focus, down through the center. They're not going to meet back here, so we're going to do dotted lines back up this way until they meet. So they're meeting back here. So there is my image. So just like for the mirror, when I get really close, it ends up being magnified and right side up and virtual. So right side up, magnified, and virtual. Any use for this is a magnifying glass. If we want to use a magnifying glass, we put it really, really close to the object we want to look at, and then the object is magnified and right side up to make it easier for us to see it.